Welcome to the latest episode of Crimes Notes. We are moving on from number expressions and equations to solving equations and applications. So now we're going to be applying what you've learned to word problems, but before we do that, I'm basically going to show you how everything kind of ties together. So remember, the goal of an equation is to get the variable by itself. And we spend an entire unit working on how to get the variable by itself. So remember, you have to use opposite operations and draw the line and all of that good stuff. So far, we've learned two methods in how to solve equations. The first one was to do it algebraically. That was the long way. And then the second way was to use InSolve. So here you should see the list and the steps that we use in order to solve algebraically. So we draw the line, then we distribute, then we combine like terms, we move variables to one side and numbers to the other, and then we solve using opposite operations. Then over here, these were your steps for InSolve. So this is your menu, algebra, numerical solve, typing in the equation, comma, the variable, and then hitting the solution. So you do have a quick review at the top of these notes if you do get stuck. So let's look at the examples that I've given you. I'm going to skip number 1 because that's kind of the easy one, and I'm going to go down and work number 2. And the whole idea is that no matter which way you solve it, you should get the correct answer. So let's look at this solution, or this equation right here. Again, it's an equation because it has an equal sign. Expressions do not have an equal sign. So if I write this out, I have 9 plus 2 parentheses 5x plus 3 equals 13x. So if we were to follow our steps, the first step is always to draw the line. Then I'm supposed to look for fractions, but I don't have any. So then next I'm supposed to distribute to get rid of parentheses, and I do have parentheses. So we would go ahead and distribute the 2. So I'm going to bring the 9 down. 2 times 5x would be positive 10x. 2 times positive 3 would be positive 6. And then on this side I didn't change anything, so I just bring that down. So now I've distributed. My next step is to combine like terms. Well, I do have some like terms. On the left side, the 9 and the plus 6 should go together. So that's 15. So I have 10x plus 15 should equal 13x. Then from here, I'm supposed to put the variables together on one side and the numbers together on the other. Well, usually I would move this to this side, but if I do that, I don't have anything left on this side. So instead, I'm going to move the 10x to this side, and remember, to do that we use opposite operations. So if I look at just the 10, it's positive, so the opposite would be to subtract 10x and subtract 10x. And what we do on one side, we always do on the other. So 10 minus 10 does cancel out. Leaves me with 15 on this side. Equals, and then over here, 13x minus 10x is 3x. So now I'm still trying to get the variable by itself. The 3 is what needs to move. This is squashed together, so this is multiplication. So the opposite would be to divide. So if I divide, these divide out, I'm left with x, and then 15 divided by 3 is 5. So I get a solution of 5. The second way that we learn to do this is much easier. It is on your calculator, and it is InSolve. So if we go into your calculator, and I go into a calculate screen, see if I put it there, you can almost see it. Then I'm supposed to go to menu. I go down to algebra, and then I pick numerical solve, so 3, 2, 1, and it pops up with InSolve here. Then remember, we're supposed to type in the equation, So it should look like this. 9 plus 2, 5x plus 3 equals 13x. And then remember our work, we're supposed to do comma, the variable, and then put all of this in parentheses so that I know exactly what it looks like when I type it in. So now I type in, inside those parentheses, 9 plus 2, parentheses, 5x plus 3, close, equals 13x. And then I'm supposed to put comma x. And now I hit enter, and it tells me my solution is 5, which we already knew from over here. So now what we're going to do, so we still got x equals 5, is we're going to prove that our answer is correct. So remember, that means you're going to go into the equation. So here's the original equation, and then parentheses 5, but now I'm going to replace this x and this x with my answer. Now let's just do this. I'm going to write out the equation, and then I'm going to replace both of these with 5s. So 9 plus 2, parentheses 5, and then my x plus 3 should equal 13 times x. And we said these should both be 5s. So now I'm going to type each side into my calculator. So 9 plus 2, parentheses 5, close, plus 3, close. And I'm going to press enter. And on the left side, I got 65. Now I'm going to type in the right side. Oh, there, I can block the light. And I would type in 13 times 5, or you could do the parentheses, and I get 65. So since 65 does equal 65, that is how I know that the answer is correct. Okay, good. So then you guys should be able to go back up and do example 1 on your own using example 2 as a example. Kind of sounds funny. So now let's flip it over onto the back. And now we're going to apply those number expressions to word problems. So the first thing that we need to do with any word problem is define the variables. So if you notice on the 2 problems below, you should see that I've given you the variables that we're going to use, but you need to tell me what they stand for. The second part is going to be to set up the equations. And you're going to do this by reading the problem. So you're going to read and write in order to set it up, just like we did when we were doing our number expressions. Then the third step is going to be to solve the equations. And then once you've solved the equations, you need to make sure that you answered the question. Because a lot of the times the answer isn't necessarily the answer to the question. So let's look at number 3. Number 3 says the larger of 2 numbers is 23. If 3 times the larger number is 5 more than 8 times the smaller number, find the smaller number. Man, hairball. I don't know what my deal is, sorry. So just reading that, I know most of you checked out because you guys don't do word problems, but hopefully you caught the 2 main subjects. One starts with an S and one starts with an L. Well, the S was the smaller number. The L stands for the larger number. So notice when I'm defining my variables, I do not use numbers. This is always going to be words. So defining the variables is just saying what does S stand for and what does L stand for. The next step is to set up the equations, and we said we're going to do that by reading through the problem. So right here it says the larger of the two numbers. So comparing the smaller and the larger one is 23. So this is your L. Is, we said, is equals, and this is 23. So this first sentence already gives us an equation. We know that L is actually equal to 23. So now we keep reading. If 3, so we put a 3, times, we said that's a dot, the larger number. Well, what stands for the larger number? Well, there's two options here. L, because that is our larger number, or we know that it's 23. For now, I'm going to go ahead and use L, but if you used 23, that would also be okay. So I'm going to put 3 times L, the larger number, is, remember that's our equal sign, so is 5 more than means plus, but again, remember this is a switch word, so once we set it up, we need to make sure that we switch. 8, so 8 times, and then the smaller number. Well, we don't know what the smaller number is, so here I would have to use the variable, and the variable is S. And then it says find the smaller number. So let's see now if we can set up this equation. 3 times L. Well, what is 3 times L? Well, it's 3L. So I would have 3L equals, then I have 5 plus 8 times S. Well, 8 times S is 8S. So there's our equation, but the problem is we still have this switch. So that means this and this need to switch places. So my equation is actually, I'm going to write it over here, 3L equals 8S plus 5. So step 3 says to solve the equation, but the problem is I've got two variables and I don't know how to solve with two variables. But if you remember, they gave us this information over here. We know that L is 23. That means I can replace L in this equation with 23. So I would say 3 times 23 equals 8S plus 5. So then you could put in your calculator 3 times 23, and you get 69. So I now have 69 equals 8S plus 5. And now you would be ready to solve for S, which is the smaller number. So I'm going to leave that for you guys to do. Go back in, solve for S, and then answer the question. That means that there should be a sentence. So your sentence should be, the smaller number is, and then whatever you get as an answer. Good. So now let's look at example 4. Example 4 says, Mr. Powell travels 24 miles to work every day. The difference between the distance Mr. Clay travels in 6 days and the distance Mr. Powell travels in 5 days is 96 miles. How many miles does Mr. Clay drive to work? So This says how many miles, so that means this has to stand for miles. So C is going to be Mr. Clay, so this is the miles that Mr. Clay drives to work. P still has to stand for miles because that's what's here, so this would be the miles that Mr. Powell drives to work. So again, we were setting up our equations. Sorry, have to get this all folded so you can actually see it. Oh, and I folded it too far and you can't see it. Let me try this again. There we go. So now we've defined the variables. Now we're ready to start to set up our equations. So we read the first sentence and it says, Mr. Powell travels 24 miles to work every day. Well, miles was one of our variables. And since it's Mr. Powell, they already told us that P equals 24 miles. So now we're going to start to set up our equations. Again, this is P, Mr. Powell, and then this was equals 24. So now the difference, so that means I'm going to be subtracting between the distance Mr. Clay travels. Well, this whole thing, the distance Mr. Clay travels, that's C. That's the miles. So we would replace this with a C. And then it says in 6 days. So here's 6 days. And then the distance that Mr. Powell travels, so we already know that that's P, and that's in 5 days. And then is 96. So the difference, so we're supposed to subtract the distance that Mr. Clay travels and the distance that Mr. Powell travels. So this is C times 6, so 6 days in C. So we would have 6C, and then the difference is subtraction. And then the distance Mr. Powell travels in 5 days, so 5P, is 96 miles. So now we've set up the equation, and now we're supposed to solve the equation, but again, I have two variables. So if I do the C, or the P that I already know is 24, so I would say 6C minus 5 times 24 is supposed to be 96. So the first thing that I would go ahead and do would be to put in 5 times 24. So I get 6 times C, his minus 120, should be 96. So now I would need to get C by itself. So I would do plus 120, plus 120. So then 6C equals 216. And then I would have to divide by 6. And I get that C equals 36. So this is a solution to the equation. But remember, with word problems, you always have to go back and answer the question. It says, how many miles does Mr. Clay drive to work? Well, C stands for the miles that he drives to work. So we would say, Mr. Clay drives 36 miles to work every day.